Hey folks, continuing with our discussion on VXLAN, we are going to be talking about the symmetric IRB, right? The integrated routing and bridging. Basically, the idea what we'll be doing now is, right? So we basically need these two guys to talk to each other, right? To this guy, right? And you can see this is in a different subnet. This is in a different subnet. This is in VNI 10010. We want to route it with 10012, right? So we want to route between these two VNIs, and that is a job of symmetric IRB. All right. So just to kind of rehash, we have done a bunch of things previously in the previous videos. We have done the underlay, which is OSPF. We have done BGP, IBGP basically, right? We've done that. Spines are working as route reflectors, right? And we have also enabled L3VPN EVPN address family within BGP, right? We also enabled L3VNI, right? And we were able to verify that this guy is able to talk to this guy because they are part of the same L3VNI, which is 10010. Okay, so with that base configurations, let's proceed with this particular video where we'll start with configuring the leaves to support the routing between the two VNIs. Okay. All right. The very first configuration is we will basically, now that when you talk about routing, right, we all know the concept of VRFs, right? It helps to create a macro segmentation so that all the traffic pertaining to one routing table is kept separate from other routing tables. So considering this data center is going to be used for multiple functionalities, what we are going to do is we'll just go to our leaf, right? Considering this will be used by multiple tenants basically, right? So let's start by creating a VRF, right? So we'll say VRF1, right? Very original name, to be honest. Then you've got, when you talk about VRF, you always have again route distinguisher, route target, right? For this guy, let's go with 65,001:1 because that's the BGP in AS number followed by the device number, I would say, or leaf 1, right? Route target as well, let's use the same one, right? You don't have to, but I'm going to keep it simple, right? So route target, right? And we're talking about doing this for EVPN. So if you do a question mark, you can see there is a EVPN route target. So we're going to enable for that. Similarly, this one is going to be import. We have done an export, so we have to do an import. All right, so that looks good. So we have enabled the VRF. The next item would be to basically go and see if we have, what do we have under the SVIs? Do we have SVIs? We don't, right? So let's go and configure that. So I'm going to conf t interface VLAN 10, right? Let's attach this to this VRF, right? Because if you want this interfaces to use this VRF, you have to attach it. Let's do IP address 10.1.10 dot, maybe let's use 2 here, and I'll explain what is this. This is very similar to how we do VRRP, right? But in Aruba, we have a very cool feature called as active gateway, right? Active gateway, by the way, is different from active forwarding. Don't get confused. We will talk about active forwarding some other day, but for active gateway, the idea is to, it's very similar to, it functions very similar to VRRP, but the only difference here is you can actually have two devices, doing load balancing. Both the devices are going to be active, right? In case of VRRP, we normally have one device as active, right? Anyway, so in our topology, this is not going to play a major, role because we are just having one leaf switch. But if you have more than one leaf switch, right? So you have say redundancy here. So you have something like VSX, then it would really matter, right? But how is it really helping us? So right now we have created a SVI, we put a IP address on it. Remember in the Cisco's world, we did something like a fabric anycast gateway, right? The reason is when this SVI is created on leaf 2, we want to use the same IP address for the gateway and same MAC address, right? So that you can do things like VM movement very easily, right? So that the ARP doesn't have to happen again, right? It can use the same this thing. So considering that, what we'll do here is, think of this as a very parallel configuration to how we did it in the Cisco's world, which is Fabric Anycast gateway, right? So I'm gonna do any active gateway, and we can define a MAC address, right? I'm gonna define a specific MAC address like 12.0.0, maybe not 0.0.1.0.0. Okay, so this MAC address gotta be same on the other gateway, on the other device, on the other leaf as well, right, for the same SWA. And then you also need a IP similar to the VRRP standby IP, right? So in our case 10.1.10.1. okay, similarly the other interface is also available, so I'm going to do interface VLAN 11, right? Let's attach the VRF1. IP address is going to be very similar to this one with a slight difference of 11.2. Active gateway, right? Active gateway, the MAC address I can use the same. Why? Because it's in a different VLAN, right? So since it is already in a different VLAN, there is segmentation, so I can reuse the MAC address, so it wouldn't be an issue. Then we have active gateway IP, right? So we're gonna do 10.1.11.1. Cool. So that's the very minimal. I think that should be the most minimal. Let's go and look at the configuration. Show run interface VLAN 10 looks good. VLAN 11 looks good, right? Let me do the same configurations on leaf 2. Give me a minute. All right, so the configs are done. We should be able to check. You can do show run VRF. So there you go. We are just changing the route distinguisher to :2 so that we understand where is what is the route distinguisher, right? We basically understand the routes are basically coming, or they're getting tagged, right, from the leaf 2, right? Then what we also do is the route target, right? The route target is going to be the same as the route target on leaf 1, because ultimately we want all of these routes to get imported into the same VRF, right? VRF routing table, because we are talking about one single tenant here, correct? So if you have one more VRF, you can create it and attach a new route target for it. Cool. Then the interfaces, show run, I think show run interface VLAN 10 is here, VLAN 12 is here. Okay, so you've got the VRF attach, IP address, active gateway, and this you have this one as well, right? So that's just the IPs are different. So here looks like we are basically using 10.1.1.4, right? Let's look at what we used here, .2, right? And here we're using .4, but doesn't really matter. This would really matter only if you had one more VSX, one more leaf, right, to give redundancy to the leaf 2. What really matters is this guy, 10.1.10.1. It is going to be the default gateway which is configured on the clients. Similarly over here as well. Cool. So that is looking good. So 10.2, 10.4, 10.1, that's good. 11.2 is good, and here 12.2 is okay. So all of that is good. All right. So now coming to the very important config, which is, remember we are talking about symmetric IRB, right? Again, I will not go through the whole difference between symmetric IRB, right? There is obviously use cases for both. I wouldn't say you always use symmetric IRB, but symmetric IRB, the requirement is that you need to have the VLANs and the L3VNI, right, on all the leaves. So if you're using 50 VLANs, you need to have all the 50 VLANs on each of the leaf and all the L3VNIs, so that you can you can basically you can take care of everything without any sort of routing. You can do bridging, right? But in case of symmetric IRB, the idea is you don't really need all the VLANs and L3VNIs on every single switch. Like this is a good example, right? Here we can see the leaf 1 just has these two L3VNIs, whereas leaf 2 has different it has the orange one, right? And the orange one is not here on the left, but still you'll be able to communicate between the yellow and the orange, right? That's the main goal of symmetric IRB, right? It helps in that way, right? Thereby reducing your tables, right? The MAC address tables, the VLANs, and corresponding L3VNI. So all of that resource consumption gets reduced. Okay, so let's proceed, right? So the next step is to configure what we call as a L3VNI. right? And we'll talk about this in the packet captures, but basically the idea is, let's go to one of the leaf. Let's clear the screen. We already have the VXLAN VTEP, right? With the L3VNI, we are just going to go inside it and configure VNI maybe 101, right? Let's use probably like 101, right, for the L3VNI over here, okay? And it is going to be routing, right? So we have to enable routing for this guy. Please configure a non-default VRF for VNI, right? So we will first configure the VRF1, sorry, I think the capital, right? And then we're gonna enable routing, okay? Similarly here as well, you know, let's go into interface VXLAN 1, VNI 101, right? VRF, attach it to the VRF, right? And then enable routing. Perfect. So that is basically what you need with respect to the L3VNI, right? In simple terms, what really happens is, now when the two L2VNIs want to talk to each other, it gets routed using the L3VNI, and then the L3VNI gets used in the VXLAN tunnel and gets sent out, right? I'll talk about the whole flow, right? But let's just move forward for now with respect to the configurations. We have the L3VNI in place, right? The next is let's also look at what is happening with respect to our route types, right? We have talked about two types of route types till now, correct? We have talked about route type 2 and route type 3, right? But there is one more route type which is necessary while using while doing routing, which is something called as a route type 5. Again, the details and the theory for this is very well explained in my previous playlist videos, right? But for asymmetric IRB, you would kind of need that, right? So let's go and enable that, right? And the reason is pretty straightforward, right? So again, coming back to the diagram here, so like I said, this particular leaf has this subnet, right? But it doesn't have this subnet, right? But for it to route, right, you always know that this guy can route to this particular subnet, right? If that particular subnet is, you know, either locally configured, right, so that it appears in the routing table, right? So otherwise, how would you do that, right? So that's the whole point of route type T. So what you do is you take this subnet, and using something called as a route type 5, you advertise it, right? And it comes down here, and this guy, right, on the leaf 1, it will be available in the routing table, right? With the whatever /24 or whatever you're using, that route subnet will be available on the leaf 1, which makes it possible for the symmetric IRB to work, which in turn makes it possible for that earlier advantage which I mentioned, which is you don't really need this subnet to be locally configured over here on this leaf, correct? So that being said, let's continue, right? So we will go ahead and how do you, now the important point is, how do you send this subnet from, say for example here, how do you send it all the way here, right? So that's pretty actually straightforward, right? So let's get into our leaf here. Let's look at our BGP configuration, right? So this is the BGP configuration. Right now we have just enabled address family L2VPN, and we have enabled the address family towards the spines. Now what we'll do is we'll get into the BGP again, right? But this time, remember, we have to enable address family IPv4 unicast, right? Because that's the address family of this. This is not a L2VPN subnet. This is a normal IP subnet, IP unicast. How do you send that over here? For that, you need to enable the address family IPv4 unicast. But you should also do that in the VRF, correct? So in our case, the VRF is VRF1. Sorry, VRF1, right? Because right now we are not doing this in the global routing table. All the client traffic is going to come into the VRF because we have put the VLANs in the VRF. Let's do address family IPv4 unicast. Okay. Now, next what we do is we do redistribute connected. So once you do this, what happens is all the connected subnets which are there here, right? In this case, 10.1.10 and 10.1.11. These subnets, right? This is not like your normal BGP configuration, right? Normally when you configure BGP, you want to advertise anything, you use the network command, right, to enable those subnets. Here what you're doing is you're just doing redistribute connected, so that all the subnets, right, we can just redistribute, right. I mean, technically you can also control this using the network command, but I mean, if you want, if you don't want to forget that there are certain subnets which you have not enabled, right, better would be to go into redistribute connect. Alright, so same configs would go on the other guy, right? So it's basically this guy, right? So let's grab this one, go here, right? So on the leaf 2 as well, we will need to do the same config. So we'll get into the VRF and we're gonna drop this, right? So let's check show run BGP. Perfect. So we have the subnet, right? So we should be getting the subnets now. Okay. So let me take a pause here and let me show you the packet captures on where these subnets are, how these subnets are basically exchanged, right? Using the BGP, which one? BGP update, EVPN update, which is type 5, route type 5. All right. So I was able to pull the packet capture, right? So as you see here, we can basically see a BGP update message going from 1.3 to 1.2, which is in our topology, leaf 1 to spine 2, right? Because both are route reflectors anyway. So the BGP neighborship is found with both the guys. But anyway, so you can see here in this particular update, what we are doing is, as you see here, rest everything we have already discussed in the past. So I'm just going to go to the important piece here, which is the reach NLRI information, right? Network reachability information. And here you can see IP prefix route. And this is the type 5, right? And as you clearly see here, the subnet, which is a subnet over here, right? 10.1, 10.0 and 10.1, 11.0. So these are the two subnets on leaf 1. It is going to the other side, right? It is basically sent to the leaf and the leaf, sorry, to spine, and spine will reflect it, right? You can also see it is getting tagged with the VNI, which is the L3VNI, which we just now created, right? 101, 101. Perfect. So that is important, right? And while we are discussing this, let me actually go down to the, so we have now what we have done is we have seen that the route type is sent, type 5 is sent, but let's go on to the switch, right? Let's go to leaf 2 and see, show BGP L2VPN EVPN, right? And you can see the subnets here, right? So you can clearly see the one which is of importance for us is the L3VNI 101 over here. You can see the two subnets are coming here, 10 and 12 network. Perfect. So this is interesting, right? And similarly, you can also see there is 101 and what is this? So this is 10.1. Yeah. So this is actually the one which is coming from the this is actually the one coming from leaf 1, right? Because you see route distinguisher. This is the one which is local. I mean, this is actually the one local to 11.5, which is leaf 2, right? So this is the one coming from the other side, and you can see it's been imported into the EVPN table. Okay, now from here, what really happens? Now that we have subnets, right, coming all the way to leaf 2, from leaf 2, from the EVPN table, it goes to, remember the MAC addresses went to the MAC address table, right? Similarly, here, show IP route, if you do on this particular VRF1, sorry, you can see that those routes will then get imported into the route table as well. You can see 10.0 is here, correct? Sorry, that's the local one, but the one which is coming from the other side is this guy, right? So you can see it is B is from BGP, right? So if leaf 2A wants to talk to, right, this particular subnet, all it has to do is use this particular next hop, right? And you can actually go one more step, right? To see the details, we can actually look at show we should be able to see the show IP route, and let's probably look at this guy, right? And maybe VRF1, right? If you look at the details, you can clearly see to reach this particular subnet, you have to use VXLAN, right? This is the VTEP IP to which it has to go to, and you can see encapsulation is L3VNI, right? So that is the main significance of the route type 5, right? So you're basically able to send the subnets which you might be connected to, but the peer might not be connected to, right? So by sending these subnets, the peer will know that how to route or how to send the traffic to that particular subnet, how to route between the subnets, right? Cool. So moving ahead. Okay, so now we are getting to an interesting concept, right? And what is that? As we looked at the routing table on leaf 2, we could clearly see that there's a subnet here, right? And we are basically telling that anything on this subnet has to be sent to this leaf. But you see, this can become a bit suboptimal, right? So what can happen is, let me use my pen here. So in this case, we just had 2 leaves, that's fine. But what if you have, right, you have a leaf here, you've got your leaf 1. So you have leaf 1, 2, and 3. Perfect. And what is really happening is, let's assume that, you have 10.1.11.0 over here, you have 10.1.11.0 over here. Okay, the subnets. And because of that, those subnets are coming in as route type 5, and they are going to come down here to this guy, right, to the leaf 3. Leaf 3 will obviously install only one of the subnet, right? Because again, typical BGP, best path, right? Only one best path. So let's say it just picked this guy. So it installed this in its routing table and said that, okay, if I want to go to this subnet, go here, right? With 1 as the next stop. Okay, but let's assume that there is a host sitting behind here, right, which is 10.1.11.15, right? So when I'm sitting here and I want to talk to this host, what is going to happen is the tunnel is gonna send the traffic all the way here, right? And from here it is going to get bridged, right? So once traffic comes down here using L3VNI, right, over here the traffic then uses L2VNI to use one more tunnel and send it back here, right? So this is not very optimal. How do you solve this? Simplest way is add the /32 routes, right? Somehow get this guy into its routing table, not just the subnet but the /32 routes as well, right? That's the solution. Right, now again you might ask a question, okay, wouldn't the tables of the switch or the leaf get exhausted if you get all the /32s? Partially yes, and there are ways to kind of fix that. There is things like optimization techniques. Basically the leaf switches, right, they only retain the /32 host where there are active EVPN traffic flows, right? So now that's probably a story for another day. You can actually read it up on the VXLAN guide as well, right? There are optimization technologies for it. For now, since our use case is very small, we will not dwell too much into that. We just want to make sure that we understand the concept, which is to reduce the suboptimal traffic flows. We need to basically make sure that we can get that /32 route into the routing table of the VRF, right? And how do we do that? So before doing that, if I go back again to the leaf 2A, right? If I look at show BGP, L3VPN, EVPN, right? You can see these are all the routes which have been learned, right? And maybe there's one more piece which I probably left out or maybe slipped my mind, which is you can see from the leaf 1, we have also received, earlier we used to receive only the MAC route, right, which is just the MAC address. But in case of Symmetric L3VNI, we are also getting the MAC address and we're also getting the IP address as well, correct? So now in this case, obviously this is, we still haven't gotten the IP address of the endpoint client because, the ARP entry is still not present on the leaf, right? So this, the MAC plus IP route, right? So basically let me just clear that doubt, right, by using the whiteboard again. So in route type 2, right, we have just the MAC route, then we have MAC plus IP. In route type 3, right, we have, what do we have? Let me just go back, right? We remember we talked about this. Route type 3 is over here, right? So that's just the IP, correct? So that's the IP, and then you have the route type 5, which is also the IP over here, right? So let's come back here. Yeah, so route type 3 is mainly for, remember we talked about this, it is for auto discovery, right? Just to make sure that the leaves know where to send the bump traffic, right? Route type 5 is mainly for IP prefix route, it is prefix subnet, okay? This is what we have. Now we have spoken about this guy before, and we just now spoke about this as well. we did not speak about this. This one is basically generated when the leaf one, right, ends up getting the IP along with the MAC, right? Now when that is possible, when this guy obviously is going to send some traffic, when it is going to do some routing, so it's going to send some traffic here, right? In that case, this guy will end up sending the traffic, it'll end up ARPing the gateway, right? It'll end up ARPing the gateway and the traffic will be sent to leaf one, and that's when the leaf one is able to do the L3 inspection. That's how it gets to know that, hey, 10.1.10.10 is present at this MAC address, which is 5000, right? Colon 5000, whatever it was. Right now it doesn't have that information because we haven't really generated any L3 traffic. So that's why, when you looked at the table here, you see in the type 2, you just see for 10.1, which is the gateway, right? You don't have for 10.1.10.10, you don't have it for 10.1.11.10 because they have not generated any routed traffic. All right, so we talked about the L2, we talked about the route type 2, which includes the MAC and the IP, right? Now coming back to the discussion, like we said, our goal is to show IP route VRF1, right? So our goal is to get our goal is to get like a specific IP and not /24. We want to get /32 over here, right? How do we do that? It's it's basically by redistributing, right? So if I go back here, so we're going to be just redistributing these type 2 routes, right, into type 5. Okay, and what do I mean by that, right? So just to kind of observe here right now, right? So we have pulled the whole L2VPN table, and let's observe, right? Right now, what do we have? And we have also verified that in the routing table we don't have the /32, correct? And let's also observe that L3VNI over here, right? It doesn't have any specific, it doesn't have the dot ones. It obviously is not going to have the client IPs because we have not generated any traffic yet, but at least the gateways, right? Even for the gateways, you can see the L3VNI table doesn't have the /32. It is present over here, but it is not present here, right? So what we'll do now is, let's go and do the configuration to enable that. So all we have to do is, let me just clear the screen. So let's get into EVPN again. Let's actually look at what we have in EVPN. So we do show run EVPN, right? This is what you have. All we gotta do is get into each of these guys and do redistribute host route, right? Let's do the same thing for the other VLAN, which is redistribute host route. Okay, same thing on the others, this thing as well. It's probably going to be EVPN, right? Let me just come out of this guy, right? Let me clear the screen a little bit. So we're gonna go into EVPN. We are going to go inside VLAN 10, redistribute host route, right? Similarly 12, redistribute host route. Perfect. So now let's see what damage this has caused, right? Actually let's look at just the routing table first. Cool. So let's just go back here, one sec. All right, so what we are going to do is show IP route VRF1. There you go, right? So you can see .1, the gateway is now present over here, right? You're not going to have 10.1 because it is locally connected anyway, so you're not going to send the traffic all the way to leaf 1, right, for 10.1. but for 11.1, you can see you're going to send it to leaf, but at the same time you're going to specifically send it to leaf 1 because the /32 is coming from there. Okay, you will still have the /24, but that's basically if this is not present. Okay, only then that will be used. Similarly on the other guy as well, we should be able to see it. Show IP route VRF1, right? So you can see 12.1 over here. Perfect. Now let's go back and investigate what has happened to the BGP route table, right? Show BGP L2VPN EVPN. Okay, there you go. Earlier, if you looked at my L3VNI over here, right? This is the L3VNI 101. You did not have this route, correct? But you see the type 2 route is now showing up under this guy, correct? Now because of this reason, this route is basically getting imported into the VRF table. So we have basically been able to get the /32 IP into the routing table for preventing suboptimal routing. So that's the whole point of redistributing the host route so that you get the /32 in the routing table. Okay. Now there's one last configuration. Again, like I said, at the beginning of this series, my whole objective with this was to kind of give you like an in-depth understanding of each and every config snippet and also get your BGP, EVPN, VXLAN up and running, right? There would be tens of other optimizations which you can do, especially on the physical hardware, which you would need to refer to the document, right? To the VXLAN solution guide from Aruba. But the main goal here has been to give you like the working configuration, especially to bring up a small VXLAN pod, right? So that basically means the one last configuration which is left is basically the virtual MAC address, right? So what really happens is, like I said, in Symmetric IRB, right? In Symmetric IRB, you're doing a MAC lookup first, and then you're doing a IP lookup, right? And in fact, I think this would be much easier if I explain it through the packet flow in a while. So for now, what you can just hold off on this thought, right? We are just adding a virtual MAC, a unique virtual MAC per VTEP, right? So it's basically going to be virtual MAC. So it's going to be probably, let's go on to the leaf 2, and I'm just going to put this particular virtual MAC. It's going to have like 02 at the end, and on the leaf 1, this is going to be 01, right? But a short answer here is why you need this is because for the inner packet, right? So for the inner packet, when you're doing a routing, right, between say two VLANs, in this case VLAN 10 and 12, you're going to have the inner packet, right? So the inner packet, the ICMP packet, whatever traffic you're generating, right? So you would basically need a destination MAC address to be put over there, right? But then you're also routing. So the whole idea here is to put the router MAC, which is also advertised during BGP, right? And this is unique per VTEP. And I will show you, like I said, in the packet flow, I will show you that. But hold on for a minute. This is mainly for the inner MAC address, inner destination MAC address, while sending the traffic using L3VNI towards the other VTEP. Okay? All right. So that being said, all the configurations have been done from our side, right? Which means let's quickly check if all our interfaces are up, right? Maybe what I would do is, let me just first look at some of the packet captures, because I think all right, so couple of things which I haven't shown you guys with the packet capture is, one is the MAC plus IP route, right? So I've pulled that up here in one of the BGP update message, and we can see that it's part of the reachability information. You can see it's MAC advertisement route. You can see the IPv4 address as well as the MAC address is sent. Perfect. You can also see it is getting attached with VNI 101 as well as 10012. Okay, so that's how it is getting imported into the L3VNI table, right? Or the IPVRF is what we normally call it. Coming back here, the other one important thing is the EVPN router MAC. You can see here the virtual MAC which we defined is also going, which is 02. I think this is from the leaf 2. You can see this is basically a request which is going from leaf 2 to one of the spines, I believe. No, this is actually coming from spines to leaf 1. It's coming to leaf 1, but it has originally come from leaf 2, right? So you can see the leaf 2 has advertised its router MAC, and I will show you where it is getting used, but I wanted to show you that it is going to be part of this particular extended communities, right? It gets sent over there. All right, cool. So now all right, so I think we have everything ready. I also have packet captures coming in, so that it's going to be handy for us to have a look at what's really happening behind the screen, right? All right, So ideally, obviously the control plane has already started, right? Because we have the SVIs turned on, right? Earlier, I did go and shut the interfaces towards the access ports, right? Towards the server, but we still have show interface VLAN 10, right? So this guy is up, right? So because of that, the 10.1, 10.0 subnet, right, would have come here as, so if I do show L3VPN EVPN, right? So CP L3VPN EVPN. So if you do that, right, you will basically see that subnet already present here. So the control plane has already started. The moment that SVI was up on leaf 1, it has found its way inside the L3VNI tables, right? So you can see 10.1 showing up here. This is the active gateway, right? The Anycast gateway which we spoke of, right? So that's already there. Similarly on the other side as well, right? On the leaf show BGP L2 VPN EVPN, right? So you already have the relevant things coming from the other side, right? So you have the type 2, you have the type 3 for the 12 VLAN, right? You also have it as part of this guy over here, right? So you have the type 5 out here for mainly the subnet, right? And you'll also have the /32 prefix in the L3VNI as well .1, right? So in the routing table also it will be present. So that part is already done, right? Now mainly I want to do is basically unshut. Let's just unshut because the main idea here is to check out the communication between these two guys, right? So I'm gonna unshut 1/1 and do a no shut. Let's also do the same thing but on this guy I will do it as 1/1/2 no shut. Perfect, because L2VNI we already verified, right? Communication between the L2VNI is already verified in the previous video. The main goal here is to check if yellow can ping orange, right? So I've done a no shut now, right? The moment I did a no shut, we should probably see some type 2 routes show up, right? Show BGP to VPN PN, right? So that we should probably see some 10 dot something on the, let me just pull this a little bit here. Yep, there you go. I think we have it. 10.0. Do we have something like 10.10? Maybe let's just filter this up to route type 2, right? So in route type 2, currently it's all .1s, right? So I don't see it yet here, so which means let's try to generate some traffic, right? So if I probably do a ping to 10.1.12.10, what is going to happen? All right, so there you go, the ping went, but you see a couple of pings were dropped, right? So that would have generated the, that would have triggered the control plane. So now let's look at, again, let's look at route type 2, and this time you can see 10.10 is present over here, right? So it is, let's come from this guy, right? So this is a route distinguisher for the leaf 1, and you can see the 10.10 is getting learnt over here, right? This is the MAC plus IP router. Okay, now that same route is getting imported into L3VNI because we did the redistribute host route, which means if I do show IP route VRF1, you should basically have that guy over here as well, right? So there you go. Perfect. So similarly, you are going to have a similar flow on the other side, right? On the leaf 1, you should basically see the 12.10, right? So that got learned, right? In addition to that, you are going to obviously have the rest of the type 2, type 5, type 3 routes. We will not get too much into it because we have talked about it already. But all right, so now once that is done, right, in fact, as you see here, it clearly says that to reach 12.10, you have to use this guy, which is leaf 2, right? So there will be a VXLAN tunnel which is going to be created, right, for that purpose, right? Probably now let's look at so how this whole workflow went through, right? Let's just probably write it down here, right? So let's just write this down, right? So that this is kind of like fixed in our head, right? So what we did was we did a ping between this guy and this guy, right? Let's forget the control plane. Control plane is done. We looked at it, all the type 2, 3, type 5, right? All those routes, they were learnt on the peer and on both the sides, right? They have been learnt for each of the end hosts, right? So all of that is fine. We're mainly talking about the data plane now. In the data plane, what happened? Step number 1, right? When this guy found that he has to talk to this guy, it obviously realized that he has to talk to a different subnet, right? So which means it has to ARP the gateway, correct? On this device I have configured the gateway as 10.1 10.1. So step number 1, right, it ARP the gateway, right, and once it got the MAC address of the gateway, it sent the packet to the gateway. Now once the traffic reached leaf, what it did was it did a MAC lookup, correct? So it looked at the packet, right? The packet would have been going from 10.10 to 10.10.1 with the source MAC address of this guy, destination MAC address of the gateway, right? So when the packet reached the leaf one, what did the leaf one do? The leaf one did a MAC lookup to see, okay, you know what, this MAC address belongs to me, right? So this packet is destined currently to me, right? So it is going to now figure out, okay, but it is also going to see in the destination IP, right? Destination IP part of the IP header, it is going to find this guy, right? So then it is going to do, so this is all is happening on leaf 1, right? This is happening on leaf 1. So it did a MAC lookup, now it is going to do a IP lookup, right? So when it does a IP lookup, right, it is going to do IP lookup in which one? In the VRF1. That is what we have been looking at, right? When it does that, it is going to find a /32, right, IP, right? So we can actually again double click that and kind of look at it. Give me 1 second, right? So just to kind of make sure this point is conveyed, so show IP, in fact here, right, you already have it. So you can see 12.10, it sees that this guy, right? It also has more information on it. You can do show IP route, grab this guy, VRF1. You can see it has to use encapsulation of this one, right? BGP EVPN and L3VNI of this guy, right? So that's what it is going to do. So coming back here, it is going to follow the instructions, right, which has been coded into the hardware, that it has to use VXLAN with that L3VNI and send the packet, right? So that's what is happening on leaf 1. On leaf 2, all right, so on leaf 2, I grab my pen here again. Okay, so we are on leaf 2 here. On the leaf 2, what is happening? The packet, the VXLAN encapsulated packet is reaching leaf 2. It is going to decapsulate it because the packet is destined to its VTEP. But once it decapsulated, it is going to do a IP lookup, right? Because once you remove the VXLAN header, and I will show you that in the packet capture, what will be left is this particular IP in the destination of the IP header. So it is going to do a IP lookup, and if it does show IP route VRF1, right, it is going to find that this 12.0 is actually connected, it's directly connected, right? So once it knows that, it is then going to do a MAC lookup. So then it is going to do a MAC lookup in what? Because it knows that this particular subnet is directly connected, it is part of this VRF, it's part of this VLAN, so it is going to do a MAC lookup and then send the traffic to this guy, right? So you see, this is the reason why it is called symmetric, because you see there is a MAC IP happening, and then in the other side, you have IP MAC. So you see it's very symmetric, right? Both the ends are doing similar operations, right? So that's why it's called a symmetric IRB. Okay. Now let's quickly look at the packet captures to understand this a little further, right? So you have the ping request which was sent from, so what has happened really is, because we have ECMP, right? I'm doing packet captures on these two interfaces. The request goes on one interface and the reply comes on the other interface. So you will basically see ICMP request here, right? So this is the ICMP request. We did the request from, we did it from 10.10 to 10.1.12.10. You can see what has really happened is it has used the L3VNI 101, right, to encapsulate. And also look at the inner packet, right? So this is the ICMP packet. This is the original IP header, right? And you can see this is where the virtual MAC plays a role, right? When it is routing, it doesn't really know the destination. It doesn't really know the MAC address of this client, right? 10.1.12.0, 12.10, right? So as a result of that, what it does is, you might argue that, hey, look, we have the MAC plus IP route, so why can't it use that? There are probably a few reasons for that, but let me just keep it simple for now, right? So what it does is, it basically uses the virtual MAC which we configured, right? So this is the virtual MAC, which is, because anyway this gets stripped out, right? So this is just once it does a L3 lookup right on the leaf 2, this is no longer used. So the only point of this guy is to make sure that leaf 2 receives this packet and then obviously decapsulates all the VXLAN part which is on the top, right? So you have the VXLAN, then you have the UDP, then you have the outer IP header, then you have the outer MAC headers, right? So this will be the MAC address of probably the spine, right? So not relevant to us. Once it decapsulates the whole VXLAN on the leaf 2, it will be left with this MAC address and it will be left with this particular route. So it's going to do a IP route first, right? And once it figures out what to do with the IP route, once it figures out that, hey, look, 10.12.10 is connected to me, it is then going to do one more MAC lookup and then send the traffic to the end host. So this is the request. Reply also is going to be similar, right? You can see the reply coming from 10.12 back in the direction. Similar concept here. You can see the virtual MAC is different. This is the virtual MAC of the leaf 1. So that's the use case of the virtual MAC. It's just to make sure that you can use that as the destination MAC address when you're sending this traffic over the VXLAN tunnel, right? This is obviously not going to be used if you're doing just L3VNI. This is going to be used only if you're doing IRB, right? L3VNI. And here also you can see the VNI of 101, which is the L3VNI. Okay. So yeah, I think that was the whole agenda for this one. At least maybe we'll do more VXLAN videos in future. But for now, I just wanted to set the baseline, right, on what is a good what is like a most skeleton configuration you would need to kind of practice Aruba L2VNI, L3VNI on a CX simulator, right? Just to summarize, we started with setting up the underlay. We set up the BGP EVPN, which is the control plane for the overlay. Then we set up the data plane of overlay, which is the VXLAN, right? The VTAPs. And finally we also did the L2VNI and L3VNI so that we can do the L2 overlays and L3 overlays over the L3 network, right? Hope you guys found this useful. This one probably was a bit lengthy, but I just wanted to kind of cover a lot of pieces here, and there are a lot of moving parts in VXLAN, so hope you are on board, right? All right, thanks a lot. Have a good one. Bye.